Yeah, thank you, Ali, and it's actually really a pleasure to see you all after about 3 years. So many familiar faces, also from a rather long-term history in working in particular on the global reanalyses. And you see that we'll talk a little bit about EUMETSAT reprocessing capabilities, but I will take a bit larger view in the beginning and then circling into the reanalysis and what we prepare for this. You see there's a pretty large team at EUMETSAT already that works in the context of C3S, so not all are paid by C3S, but many are working. But then there are tons of other people that actually support us in that work, and they're even more than would fit on the slide here. So as I said, so this is basically very similar to what Han just showed. So of course, if you are operating space missions, what you see on the left, which is so basically providing the backbone for all these observations, our meteorological long-term sustained observation system, and also developing and bringing into space and operating Copernicus missions, and EUMETSAT does it, for example, for altimetry and also for the CO2M, which has a profound effect not only on C3S but also on CAMS, of course. Of course, then we do a lot with these data. We have also big archives, and we do data rescue activities. And then the reprocessing is basically coming when you go from the left pillar to the first, to the right. This is where we produce climate data records. And we do this, of course, for just ECVs that Han mentioned. So this periodically renewed framework of GCOS ECVs has basically glued all the activities already together, and it's a good anchor where we can all have the same understanding of what is meant with these ECVs. And that helps a lot in passing on stuff from the data side to the more service-oriented side to the right. Of course, on the right you see application layers, and there is the Copernicus Climate Change Service, but it's not the only one that is basically served by the data, because there's also the big research land, and that I just mimicked by WCRP here, and that has a big effect also on the IPCC that goes back into your service, of course. But there's also what we heard in the beginning by Gerard about the national climate service providers or climate information providers that make also a profound direct use of satellite observations, so not only model outputs, but also direct observations like in photovoltaic consultation systems, and they just use satellite products, and they earn about 4 million customers with this directly. So we have also, so what Carlo mentioned, a national collaboration program. We just started similar activities, and of course we can work together with C3S, and we did in this first initial workshop that we had. And with this, of course, we hope that we reach downstream into the decision making, which is far away from the mandate of a space agency, of course, but we need to make that link and learn about the feedback so that we actually produce the right measurements on the far left. Okay, and this is so just what we do. So EUMETSAT has also something which is called the Satellite Application Facility Network that produce a large set of ECVs like ICE-10, sunshine duration, soil moisture, and you see all these anomalies. They're basically monitoring droughts in recent years. But then there are also things produced in the C3S directly, like long series of atmospheric motion vectors in the polar areas for data assimilation, and then there are other things like radio occultation data that also go into the global reanalyses. So this is what we produce, and then you can see that very nicely. You can see what the impact is made on the C3S state of the climate report. Very nicely, CMWF is actually listing what they have used. This makes the task very easy, and I love it really, to have a quick assessment what has been used, also compared to last year. Is there more or less maybe? So it's a good quality indicator gate for many of the products also in our SAF network. So overall this looks pretty successful, and there's of course a big input on the top into the era 5 or later into the era 6. A little look into history when it comes to reanalyses, and we should not forget about this as we are carried further downstream into services, and we have heard a lot about the applications and the importance of those, that there was always, it's a long road that we came to get to the status where we are today. If you remember times of the era 40 at EUMETSAT, so there was already interest in satellite data, but there was basically nothing more than best effort, probably less than one person that was doing some work on providing some satellite data or atmospheric motion vectors to Era 40. R&D in that context was pretty much ad hoc. There was no program, no project, no nothing. Only about in 2010-11, I think the most groundbreaking thing that we started was this project ERA-CLIM that ECMWF was bringing up. We became part of it, and this had a profound effect, basically, on going in EUMETSAT, increasing the people working with this, increasing the infrastructure, because we were supposed to process data, and we had only ground segments where you can't easily process data. So for the first time, we built up a tiny system, because, as you can imagine, there were no resources provided by the project on infrastructure. And then there was, of course, a follow-on project. Luckily, it stopped because we went over into the services. And then we had some other projects that actually helped a lot with also doing a lot of science on quantifying uncertainties and using reference data to document and trace uncertainties, and further on. On the way, about 2016, the C3S was starting, and we did the first agreement between EUMETSAT and ECMWF to, in a sustainable, operational way, provide input data to the global reanalyses, although this was only 2 years before the cutoff for the ERA 5, so there was not much time actually to produce anything that was not already done in the precursor project. And we have a second agreement now that runs until 27, and you can see how within EUMETSAT the infrastructure evolution is going on to bigger and bigger systems that become more effective and efficient to do the reprocessing, which is very important. And it's only through the learning, through these first projects, basically, that we are able to bring up the requirements for such systems. What you see on the upper right were still our words. Since about the end of 2019, so since almost the start of the pandemic, there are no follow-up research projects that are fundamental to the input data, to the reanalyses, although each of the projects ended up with a long list of unsolved problems. So I think we should probably get together and find out what a meaningful research project could be, although we all understand that there are a lot of downstream things and research projects that the EC should fund as well. But we should not forget about this work in the future. So time is progressing, and so we have produced a lot of data sets, and we just assessed what was in there. It's a lot of reprocessed and a lot of other data that go into this. So for C3S2, we plan to work on new data which have never seen the data assimilation system, like you see up there, the SSMT, so temperature sounder, in the 1980s. So this is a new data set that has never been used in reanalysis, so we just work that up so that you can basically use that. There are also, in collaboration with another project in C3S, things like the THIR-AMV, so that's a Nimbus 4, 5, 6, and 7 infrared sounder that we try to do polar atmospheric motion vectors, and this starts basically in 1970. So that's very novel information where you don't have any of those informations in the reanalysis. So you see already, we concentrate on gaps in time or in vertical structure in the atmosphere that could be filled, and expect, of course, that those would have the biggest impact on the quality of the reanalysis by filling those gaps. And I think with Bill, we thought about 2 years about that, what missions that might be, and this is basically the list of things that we're going to address. And you see crosses on those, because most of those actually provide a bridge into the future for our upcoming MTG, EPSSG, and many Copernicus missions. So this is really creating the long-term perspective of data of similar type from the 1970s into the commitment with our operational missions basically in the 2040s. So we are approaching about 70 years and 80 years of data at the end of those programs with a complete consistent treatment of the data and the uncertainties and the data assimilation process into the reanalyses. And I think that we can do this is the consequence of these research projects and these continuous agreements with C3S. We also work beyond that. So in C3S, I think in the COP1, we produced something like uncertainty quantified humidity sounder data records, and you see just time series of brightness temperatures here. The greenish ones up there, these are the EUMETSAT MEDOPS and the SNPP, so the NOAA instrument. And then you see also some Chinese instrument that we also tried, which is very difficult because there's always missing information that you need to replace by some knowledge or asking people, and you are never perfect in that. And of course, assimilating this is very difficult, as we have just seen this morning, particularly for the Chinese, but we had also developed in this Fiducio project a harmonization approach, And this we have now further developed outside of the C3S, and with this you can actually really bring down the systematic differences between these measurements to very low levels that should actually ease bias corrections. And I think the morning we just agreed it's a worth try to see how the data assimilation systems would react in a trial system if you would use such data. And I was just noticed I need to speed up. I leave that out. Radiative transfer tooling is very important. And for many, many purposes, you will find this example that compares the time series of many different instruments, where there are instrument reasons, but also model data input reasons to the radiative transfer that give the differences. We'll just make you one last point on a really drilling into a very thick wooden board is addressing all the geostationary measurements on Earth. So EUMETSAT is doing the meteosats, which you see in the center here, longitude 0 degrees, and then since the 90s about the Indian Ocean. There's still gaps in the 90s in the Indian Ocean, so we still try to find data from India to fill gaps. We know there are some data available. We don't know much about the quality. And of course, we need to care for the future when the MTG is going to be launched later this year. This is big data, so how to deal with this? And we have the similar problem in the United States with the GOES-R and also Himawari in Japan. So doing all data in one pot and working with it doesn't work anymore. So we need some more evolution on the technology. The administration change in the United States for the first time since at least 10 years allows now to do a joint project with NOAA. And we do actually two sub-projects in this joint project with NOAA that really will redo the whole geo-ring in terms of radiances. And they have started with looking back at rescue of their goals 1 to 7 and found out that everybody thought, if you don't really carefully read, they had 3-hourly global disk sampling. This isn't true. They have 30-minute sampling. And the data are sitting on a disk where they have never been utilized other than bringing from tape to disk. So now they have a project, a funded project, to work on that, and we will utilize them. And you can imagine that this will do much better winds and radiances for your data assimilation. The last slide, how do we approach this? Cloud infrastructure is very important, and EUMETSAT and ECMWF have this partnership on the European Weather Cloud. We did a lot of tests with others on interoperability of these cloud systems, so we're going to work with NOAA on really using also their cloud systems. They work mostly in the Amazon or Microsoft Azure, and then we can do all these kind of things from sharing best breed code and so forth to make this processing really efficient so that we do not need transport data anymore. No? Only certain representations of the data later on, not the raw data, the petabytes, no? So that we may only do terabytes for the reanalysis. So the take-home message, I think we are and will remain as an essential partner of C3S and operating the missions and contributing to the data records for the reanalysis, but also in general in terms of GCOS ECVs. Our capabilities are the result of learning in the projects and now in real operational context, long-term investment in the infrastructure, and people development. You should not forget that. You cannot calibrate historical observations just on the fly. You cannot find anybody on the market who can actually do this, so you need to learn that. Capabilities are really allowing effective, efficient scientific data stewardship, really from raw data down to products, which is very good. Science-oriented tooling is important, and the new technology, cloud computing, really offers new opportunities in how we can actually collaborate around the world with very much easing the data transfer needs in this business. And this is an important point as well. Thank you very much.